الرحمن الرحيم. الصلاة والسلام على محمد وعلى آله الطاهرين. السلام عليكم جميعا. إن شاء الله طاعتكم مقبولة. أهلا وسهلا بكم. Okay. We was in the digital image processing and in the part 2 image enhancement. Okay. Salam كلكم and salam aday. And said about some introduction about spatial enhancement. Okay. And the next one we said we are ready for histogram or histogram equalization. Okay. And this time and the next time we are speaking about histogram equalization. Okay. Or enhancing the histogram of an image. Salam. Okay. Why? I stop share and share my screen for this only this page, and again I go back to this document share. Okay, I share my screen. That's it. This is my screen. You see it. Here. This is the first page. This was histogram equalization, and this is definition of image histogram. What is histogram? Okay. Consider an image with intensity RK or greater level of RK, K from 0 to, for example, L, okay, or L minus 1. And image size is, for example, M by N. That's right. The number of pixels with intensity RK, for example, is NK. The histogram of the image is the function HRK, okay, or FRK. H means histogram. That means HRK is NK. The normalized histogram is the function PRK, okay. That means normalized. That means NK divided by total of pixels. That means NK divided by M dot N for all of K. This is the definition of histogram. Okay, but in these slides, in these images, we see better the meaning of histogram. Okay, for example, this is an dark image. Okay, and we see that the intensities, okay, the intensities are here, located here. This is 0, for example, this is 255. Okay, this area is for dark intensities or lower intensities, dark areas, and this area, okay, or this intensities, gray level intensities is for bright areas. Okay. Salam, Mr. Ahmed. Salam. Salam. Okay. When you see this histogram, you know that the corresponding image is a dark image, and you see it. A dark image, the gray levels are located in the lower areas, okay, or dark area. But for example, this item, this is a bright image, and we see that the gray levels is located here, near to the maximum. Okay. Another one, dark and bright. dark and bright. In dark or gray levels or intensities are near zero, and in bright or intensities are near, for example, 255, okay, or second half. But another one, between low contrast and high contrast, okay, this image is an low contrast image, and this image is an high contrast image, okay. You see in the histogram that all intensities or all gray level intensities, gray levels, are located, okay, for example, located here in a small range of intensities or of hours, okay, for example, from 100 to 120, for example. But in a high contrast image, you see that the gray levels are expanded, not compacted, okay, expanded. That means from zero to from near zero to near, for example, high value, for example, about 255. That's right. This is a extended range of gray levels. That means high contrast. You see a more range of gray levels here. That means high contrast. But you see not more range. All the range are the same, okay, or near each other. That means a low contrast. And in the histogram patterns. That's right. Because of quality of web, I stop my screen share. I stop my screen share and stop sharing and go for sharing my document. Share that document in histogram processing. That's right. We had this page in my screen, and go for the next slide. Okay. Generic figures of histograms. We said this histogram is for a dark image. Okay. Gray levels or intensities are located in the lower half. This is a histogram of a bright image. Gray levels are located in the high valued or second half. Okay. This is a low contrast image. Compacted gray levels to each other. Okay. A low range, but a extended range. Okay, extended range means a high contrast image. And we read this item: the appearance of histogram reveals a lot of information about the contrast of the image and the mean gray level. Okay, mean gray level for darkness or brightness, and compactness or extension is for low contrasting or for high contrasting. That's right. And an image of low contrast, this item has a histogram that is concentrated around a small range, okay, of intensities. But images of high contrast, this item, are more interesting and pleasant for the human eye. We can see better the images of high contrast. Okay, high contrast. We saw in the last image in my screen, not here in my screen. Okay, go to the next slide. Another one. In this slide, we see that having only histogram isn't enough. Histogram is very good, okay, but isn't enough, and we need other informations for definition of our image. For example, Here, two different images with the same histogram. This is an image. This is another image. Okay? But both of them have the same histogram. This is original image and this is sorted version. Okay? All of them have this histogram. But you don't know this histogram is for this item or for this item. Okay? Here, the appearance of histogram reveals a lot of information about the contrast of the image and the main gear level. Okay, from the last slide. But it doesn't give any information regarding the location or the type of objects presented in the image. I don't know, for example, this item is very bright. Okay, this bright is here or is here or is here. Okay, I don't know. Only I know that some pixels have this gray level, but I don't know where is the spatial location of that pixels. Okay, bright is here or here, or dark is here or here. Okay, I don't know. Histogram don't give us any spatial information. Doesn't. Okay, doesn't give us any spatial information for pixels. That's right. This information is important. What information? The spatial information. Okay, a location. It does not give any information regarding the location of or the type of objects presented in the image. This information, that means spatial information of pixels. This information is important because it's related to the image content. Okay, this content, etc. Two images can have identical histograms, this image and this image, and the same histogram, and still be completely different. This is completely different from this image in terms of content. That's right. That means in this slide we know that histogram isn't enough. Histogram is very good for defining darkness or brightness and contrast level. Okay, contrast level of an image, but there's an enough for knowing, for example, the contents of some parts of all parts of the image. Go to the next slide. Histogram processing or enhancing. Definition of intensity transformation. Okay, some transformation from histogram from the first one to an enhanced one. Okay. Consider for the moment continuous intensity values. For example, R from 0 to L minus 1. These are intensities, okay, or gray levels from the original picture. The value R0 represents full black, and the value L minus 1 represents full white. Okay, for example, from 0 to 255. 255 is full white and full bright, and 0 is full black. We are looking for intensity transformations of the form S is TAR. Okay, all over the range of grayscales. For enhancing the histogram of image. Okay, the following conditions are imposed on TAR. If our TAR has these conditions, it's a good TAR for bettering or for improving the histogram of the image, of the original image. The first one, TAR is or be monetically increasing. Okay, monetically increasing in full range from 0 to L minus 1, or better, strictly monetically increasing. okay, in that full range. The above condition guarantees that ordering of the output intensity values will follow the ordering of the input intensity values, or avoids reversal of intensity. That means, for example, if R2 is bigger than R1, S2 is bigger than S1. Okay, here, before continuing, you see the next slide. For example, this is an strictly monotonically, and this is monotonically. Okay, by this function or by this transform, this is R axis, the original Geary levels or intensities, and this is S and axis. Okay, the resultant Geary levels or intensities. Okay, you see that for example, R2 is more than R1, then S2 is more than S1. Okay, this is the importance of increasing function or increasing monotonically increasing transform. Okay, but this is strictly increasing. This is only increasing, not strictly. Okay, but this we say about strictly and not strictly in strictly and not strictly in this slide. But we go back. This is an monotonically increasing. Okay, this is good. This is good. That's it. TR should be monotonically increasing in full range or strictly monotonically increasing in the full range of intensities. The above condition guarantees that our ordering of the output intensity values will follow the ordering of the input intensity values. That means if R2 is more than R1, then S2 is more than S1. That's right. If TR transform is strictly monotonically increasing, then the mapping from S back to R will be 1 by 1. That means if here, if we use this transformation, or transformation is reversible, okay, we can go from the resultant histogram to the first or original histogram. But this isn't this item. This is increasing, okay, and monotonically increasing. But this item isn't reversible, and you can't go from resultant histogram to the original histogram. Okay, why? Because in the reverse, this area isn't a function. Okay, for example, from this SK, okay, from this SK, you have some multiple values for RK. Okay, and when reversing, this isn't a function. Some SK gives us some multiple RKs. Okay, this isn't reversible, but this is reversible. This is good. A strictly monotonically function is a good transform for enhancing an image histogram. Okay, if we need reversing. Okay, but if we didn't need any reversing, this is also good. Go to next previous slide. If TR was strictly monotonically increasing, then the mapping from S to R, reverse S to R, okay, will be 1 by 1. Another one, S or TR is in full range for R in full range. That means R is from 0 to, for example, 255. Then S or TR is extended from 0 to 255. Okay, a full range maps to a full range. should be this condition. This condition guarantees that the range of intensities of the output will be the same as the range of the full range. The full range of intensities of the output will be the same as the full range of the input. Okay, in the input. Go to the next slide. In the figure on the left here, not strictly monotonically increasing, not, okay? We cannot perform inverse mapping. That means from S to R. Why? This is because there is a case when a single value as a Q, for example, this item as a Q, is the mapping of multiple original intensities, RK1, RK2, RK3, for example. That's right. And this isn't reversible because of this area. This isn't reversible. But here, each point in SAK has only one point in RK and vice versa. Okay, that means this item or this transformation is reversible. In the above figure on the right here, inverse mapping is possible. Go to the next slide. Another one. Modeling intensities as continuous variables. Okay. Assume that an original intensity R, intensity from the original image, is mapped to an intensity S, okay, resultant, through the transformation S called by TR. Okay, we use TR and transfer from R to S. We can view intensities R and S as random variables, for example. Instead of histograms, we use okay, we use probability density functions or PDFs. Okay, probability density functions. PDFs of PRR for original image and PSS for resultant image. Okay, and see some properties for these PDFs. Probability density function. In Iran, we say to probability density function or PDF, we say چگالی احتمال probability density function تابع چگالی احتمال. تابع is the same in Persian and in Arabic. تابع, okay. احتمال is the same for Persian and Arabic, okay. But چگالی is only in Persian. Density. What do you say to density in Arabic? Do you hear me? What is the meaning of density in Arabic? مثل عباس، مثل احمد، مثل دلال، مثل زنا. مدینه؟ No. This isn't حضور غیاب. Mrs. Dalal, I had a question. What is the meaning of density in Arabic? In Persian we say چگالی. Okay. Probability in Arabic is احتمال. Okay. Function in Arabic is تابع. Okay. What is the meaning of density in Arabic? Density. Right up here. What is the Arabic meaning of density? طب الأسنان? No. Oh, Mrs. Maryam, طب الأسنان is dentist, not density. No. احتمالیه is probability. Probability means احتمالیه. Density in Arabic. I can use Google Translate. Okay. I saw in the translates said كثافة. Why كثافة? I don't know. Okay. In Persian we say كثافة reverse of نظافة. We say تمیز or نظیف and كثيف. What about density? Okay, I don't know. That's right. PDF, probability density function. Okay. You know PDF in your, for example, in your probability courses. PDF. That's right. We are studying about PRR, PDF of input image, and PDF of output intensities image. Okay. Consider a minimal increment of the original intensity R to the intensity R plus DAR. Okay, going from R to R plus DR. Then the intensity R plus DAR is mapped to an intensity SA plus DS. Okay, in the resultant image through this transformation. Since TR is monotonically increasing, okay, we can easily say that SA plus DAS is more than S. Why? Because R plus DAR is more than R. Then S plus DAS is more than S. That means DAS is when DAR is positive, DAS is positive. Okay. All values of the original intensity, which are within the intensity interval R and R plus DAR, will be mapped to new values within this range. Okay, from S. We can say that probability original intensities between R and R plus DAR is equal by probability of new intensities, new images intensities between S and SA plus DS. Okay, or in mathematical terms, integral of PR PRW DW. Okay, P original, R is for original. PRW DW from R to R plus DR is equal by PSW DW from S to S plus DS. Okay. Or in the next slide, we had this. If DR is small enough, we can assume that PRR remains almost constant within this interval. And for example, maybe equal by PRR. Okay, not PRW, constant and PRR. We can choose DR to be as small as to be able to assume that DS is also small enough, and PSS remains almost constant within that interval. Okay, then this integral, this equality, okay, tends to PRR DR is equal by PSS DS. Okay, because DR and DS are very small. It means that PRR DR, this is an area. Okay, PRR DR. This is the length and this is the height. Okay, PRR DR is PSS DS. The analysis is depicted in the next slide here. Here, for example, this is the PR. Okay, this is X and this is Y, or this is R and this is S. Okay, Y is Fx means TR, S is TR, and PXX is PRR. Okay, this is original PDF, and this is the resultant PDF. This is PSS. Mrs. Dalal, لطفاً or please لطفاً به جای یه شیفت X بگیرین. اینجوری نگاه خراب نوشته میشه. Please type shift X instead of yeah and then again type. Okay, I can't read this. اگه فارسی متوجه میشین بگم. خب به جای یه شیفت X بنویسین. احسنتون. دوباره بنویسین، من ببینم چی نوشتین. دوباره تایپ کنین. هر جا یه بود به جای شیفت X بزنین. شیفت با X. دوباره بنویسین. Please type again. While Mrs. Dalal is typing, I continue. This is PXX or PRR. Okay, this is range of R, and this is PSS. Okay, or PY. This is S. You know that this area, PX, this is PX. PX DX. Okay, this is PX DX. This area. This مساحت, okay, is equal by this item. All of this is PYY DY or PSS DS. That means if DY is more than or larger than DS or DR, okay, DS is more than DR, then PAS, this ارتفاع, this height, okay, is smaller than PR, okay. Or using this slope, okay, this slope. This slope is high compared to this slope. This slope is low. When sloping is high, dy or ds is more than dx or dr. Then P is smaller. PS is smaller than PR. But here a low slope. dy is small, then PY or PAS is large. That's right. The multiply of this width by this height is constant. If this area is smaller, this area is larger, and vice versa. Okay, means PY dy is PX dx or PAS DAS is PR DR. Mrs. دنا تایپ نکردین. خانم دنا گفتم دوباره تایپ کن ببینم چی نوشتی. متوجه میشی چی میگم؟ فارسی میتونی حرف بزنی میکروفون وصل بکنم خانم دنا؟ خانم دنا، خانم دلال فارسی میتونی صحبت کنین میکروفونتون رو وصل کنم ببینم چطوری صحبت میکنین.
بله دکتر سلام. عصر شما بخیر دکتر.
سلام، الان میکروفون وصله. یکم صحبت کنیم ببینم چطور صحبت میکنین. خانم دلال اصلا بریم. سلام خوبین؟ قربان شما، قربان شما، طاعتتون قبول بشه.
حالت خوبه.
خب شما خوب صحبت میکنین ماشاءالله. خوب صحبت میکنین. در شکر. یه سوال بکنم، اونجا چی نوشتین؟
بله دکتر.
اونجا چی تایپ کردین؟ چی نوشتین؟
صدا منخفض دکتر.
گفتم چی تایپ کردین؟ متوجه نشدم. چی تایپ کردین؟ خانم دلال، همسرتون داره قرآن میخونن؟
بله دکتر.
احسنتم. سلام برسونید.
بله دكتور، الآن داخل غزة
دكتور. قرآن جان داخل غزة صدای قرآن داره میاد. احسنتم. خب کدوم شهرین شما الان؟ أي مدينة؟
بلن دكتور، من نام دلال علي خلف است من دار سالية هزار ناساد مشتاد ذيك ميلادي من دار عراق بدنيا أمدا من متأهل هستم من يك بصرم كبغز ب6 سالة دارم بالليسانس مهندس كمبيوتر بزم فراز من أهل العراق هستم من دار بغداد كاظمية زندكي ميكانم قد كاظمية مقدس.
الان کاظمین هستین؟
بله دکتر. من کارمند وزارت آموزش ورزش هستم.
سلام برسونین امام کاظمینا.
سلامتی دکتر.
رفتین سلام برسونین. خب ایوالله، حال کردم. خوب صحبت میکنین ماشاءالله.
متشکرم دکتر. دکتر خیلی صدا ضعیف است.
ببخشید.
داخل بغداد.
ضعیف ها؟ آها. شما الان بغدادین یا کاظمینین؟
بله دکتر.
الان کجایین؟ بغداد یا کاظمین؟
بغداد در کاظمیه زندگی میکنم.
اوکی. بغداد. اوکی. That's right. اوکی. متوجه شدم. خیلی خوب. فعلا فرمایش ندارین من ادامه بدم.
بله دكتور، من يكم زبان فارسي صحبة میکنم.
خوبه. That's right. بله میگن که کاظمیه قریب به بغداد.
بله قریب دکتر.
قریب به بغداد. اوکی احسن.
وسط بغداد دکتر.
30 کیلومتر.
وسط بغداد است.
About 30 kilometers from Baghdad.
خیلی خوب. کاظمیه زیبا. خیلی زیبا.
Okay, 30 kilometers from Baghdad. Okay, that's right. Okay, Ahsan. I continue. And I disconnect your microphone. Not disconnect. Hearing the voice of Quran, okay, is very nice. That's right. Okay, continue. Be here. Histogram equalization, okay, and continuous form. A transformation of particular importance in image processing is the CDF, okay, you know PDF and CDF. PDF means probability density function and CDF means cumulative, okay, or cumulative. Integral of PDF. Okay, CDF is integral of PDF, or in discrete mode, sum of PDF. That's right. Okay, here we type here CDF for S. S is TR is L minus 1 all range integral from 0 to R P R W dW. Okay, it's an increasing function. CDF is an increasing function. Why? Since for R2 bigger than R1, we see that for example S2 is TR2 or L minus 1 dot integral from 0 to R2 PRW dW, or from 0 to R1 plus pi from R1 to R2. Okay, from 0 to R1 is this item is TR1 plus by this item. Okay, that means this is more than 0. That means TR2 is greater than TR1. You know that, for example, I type here, for example, I show, for example, maybe PDF be as here. Maybe this is PDF, okay? Maybe this is PDF, probability density function. But this is CDF. This is CDF. Oh, where is it? This is CDF. Cumulative, okay, cumulative, or we say in Iran cumulative, okay, CDF, not decreasing, every time increasing. CDF is sigma, every time is increasing, but PDF maybe here is decreasing, here is increasing, here is decreasing. That's right. Okay, here we showed previously that PAR, okay, DAR is PSS DS, or PAR DR is PSDS. Again, PS is PAR dot DR divided by DS, or is PAR over DS divided by DR. Okay, we know that this S was L minus 1 integral from 0 to R PR dW. Okay, this is CDF. And what for DS to DR? DS to DR is DS is TR. Okay, TR over DR. Substituting TR means this is TR. Okay, and here you see means L minus 1 d by dr d to dr is integral from 0 to r, for example, PRW dW, d by dr by integral are inverse of each other. Okay, inverse of each other. That means L minus 1 PRR. Okay, ds by dr is this item, this scalar PRR. Again here, PS is PR over this item. PS is PR over this item means PR over this item. Okay, and PR is resultant by this PR means 1 over L minus 1. Okay, what about all of S? PSS is independent of S. Okay, we say مستقل of S. What be S? S1, 2, 3, etc. PS is, for example, 1 over 255. Constant. Okay, flat all over the range. Therefore, the new variable is uniformly distributed or flat. Okay, the PDF of uniform is very good for resultant histogram. We had these items in the continuous mode, for example in integral, but for real images we are in the discrete areas. Okay, here histogram equalization in discrete case. Okay, the formula for histogram equalization is in the discrete case is given by a straightforward modification of the formula that corresponds to the continuous time case. Okay, that means integral is transferred to sigma. Okay, very simple. The discrete input intensity RK is mapped onto a new discrete intensity SAK, RK to SAK, through the following transformation. For example, SAK is T RK or is L minus 1. Instead of integral, we say sigma. Sigma from 0 to K, PR, okay, or PR R, okay, PR R. What is R? R from 0 to, or RJ, okay, from 0 to K, for example. That means here we see that PR means NJ over MN. Okay, in the, for example, the second slide, normalized. I go back. No. Oh, that item that isn't here. Okay, we said PRR is NK over M dot N. Okay, and we used that item here. This is a slide. This is a slide. Instead of PRR, we use NK or NJ over MN. And because M dot N is constant, is outwarding from this sigma, okay? And SK is this scalar, is constant multiplier, okay? Dot this sigma. Go to the next slide. You know these items. RK is input intensity or input array level. SK is output or resultant or new intensity or array level. And J is frequency of intensity J, or for example, repeatedness of it. Okay, how many repeated in the image? This gray level, okay, or this intensity. And M dot N is total number of image pixels. You know it. Continued of discrete case. In the ideal continuous case, histogram equalization, in the ideal, comma, in the ideal continuous case, comma, histogram equalization produces a new variable S which is uniformly distributed. We saw that, okay? We saw this here. S is uniformly distributed for continuous time, okay? For continuous PDF, not time. For continuous spatial domain. In the discrete case, the histogram of the new discrete variable SK is far from flat, isn't flat. In the continuous, we got a completely flat. Okay, S was 1 over L minus 1, completely flat. Okay, a fixed, a constant, all over the range. Okay, from 0 to L minus 1. But in the real one, images are discrete, not continuous. Okay, some pixels, some samples, and discrete. Here, the resultant histogram isn't fully flat, but is better than the original, flatter than the original image, or histogram of original image. Okay, here isn't flat, but the new histogram, resultant histogram, SK, is still much more stretched or extended, okay, or flattened versus the original, than the original histogram. We see in the next slides some examples, okay, some good examples. The new intensity variable always reaches white, or always reaches the full range, okay, since SLM minus 1 is a total, okay. This is meaning of CDF. As a total is transform of L total Ln minus 1, okay, means L minus 1 is sigma from 0 to the total L minus 1 PRR, okay. This sigma from 0 to L minus 1 is 1. You know that sigma, all of probabilities is 1, okay. All of ihtimalats is 1. That means 1 dot L minus 1 is L minus 1. S total is the total. For example, S if R was 255, S is 255. In other words, this process usually results in an enhanced image, okay, with an increase in the dynamic range of pixel values. For example, maybe in the R domain. R domain means the gray levels of original image, okay, or intensity of original image. Maybe your R is from 0 to 100, for example, but we proved that your S is 255 to full range. That means the area of the resultant intensity is more than the area of the original image, okay. This is increasing dynamic range, okay, or expanding or extending or stretching. All of these are the same, okay, of intensities of the original to the resultant. What we say in some examples. For example, here is a good slide. Histogram equalization in discrete case. These two figures, okay. This is before equalization. This is histogram of an original image. We don't see the image itself, but this is its histogram, okay. Excuse me. This is the original histogram, but this is the resultant histogram, okay, after equalization, before equalization, after equalization. You see that, for example, here intensities are from 0 to, for example, less than 200, for example, about 150, okay, about 150. But here you see from 0 to full range, this is 250. That means this is 255 L minus 1. This is a more range, okay, that this one, okay. This is about 150. What this is exactly, not about, exactly 250 55. Okay, that means increasing dynamic range of intensity from R to S. Here, in the figure below, you can see how histogram could look like after equalizing a digital image from original to the resultant. It's more extended here and slightly flatter or flattened. You see, for example, you see some sharpness here, okay? Some sharpness here, but this is more flat than this one, not full flat, okay? No, but flatter than this one or better than this one, okay, compared to the original histogram. Go to the next slide. Here you see some examples in some slides, okay? For example, here, I zoom in it. This is original image, a dark image, okay, and a low contrast image, dark and low contrast. But this is the equalized image, okay, better than this one, more brighter, and more contrast, okay, or higher contrast. What about histogram? This is the histogram of original image, okay? This image has this histogram. Firstly, located in the low R's, okay? Near the zero. Located here, okay? But this histogram is for the resultant image. Histogram is firstly extended from this area to this area, okay, to this area, and some, not totally, some flattened compared to this sharp one, okay, this sharp one. Another example, this original image, a dark and low contrast, okay, and this is the resultant, but or enhanced version. What about histogram? This dark and low contrast has this histogram. You see, compacted, okay, compacted in this area. But the resultant, the enhanced version, you see a full range from 0 to 255, okay, and some flattened compared to this one, some flattened, no totally flattened, okay, and you see this image is very better than this image, more contrast and brighter. Go to the next slide and another example. For example, here an image from the surface of moon or some star, for example, okay, maybe from moon, and this is the resultant or enhanced image, okay, or equalized image. This image is very better and has more information in it compared to this original one. What about histograms? This is the histogram of the original, very compacted, okay, very compact. But this item is expanded, okay, expanded and some flattened, not totally flattened. You see some items here from 0 to 255. All of these items have some values, okay. Another example, this is an original image. This is the enhanced version, the equalized. This item is more than this item. more contrast. Okay, you see, excuse me, only original histogram, not the resultant. Not the resultant. You know that for resultant you can see in the book, but the resultant is flattened compared to this one. Next slide. For example, you see here in another image. This is an original image, dark and low contrast. This is a better image, okay, using the histogram enhancement. And you see the first histogram and the resultant histogram expanded and flattened, okay. This is the CDF for the original. Another example, for example, this portion of the face, okay, this is some dark and low contrast, but this is better, high contrast, her eye, okay, compared to this one. And this is the original histogram, and this is the resultant histogram, okay. You see that the resultant is flattened. You see here better, flattened compared to this one. Here you see low, very low. Here you see better. Okay, this histogram is flattened compared to this one. Go to the next one. For example, a car. Okay. A tire of a car. You see this item is dark, okay, very dark, and this is the histogram located here near 0, dark, okay. But the resultant and enhanced version, you see the histogram is flattened and extended over the full range. Here you have some small intensities, okay, but you see some large intensities, flattened compared to this one, better, okay. Another example, this item. This is the original version, and this is the resultant version. This resultant has some more information, okay, compared to this one. Another example. Here you see a bridge and a black bridge, okay, for example, in the night, a picture in the night. You see the histogram located near the 0, okay, 0 intensities. But you see this enhanced version, okay, is very better than this one. You see more brightness, okay, and you see the histogram is flattened all over the range. Here you see you saw some very small intensities, okay, but you see here is better and expanded, okay, your histogram all over the range, okay. This here is very enhanced compared to this one. Another example, maybe here, another example. You see a family, a dark and low contrast, okay, or brighter, okay, or brighter, and better contrast, okay, better quality, totally, better quality, totally. But this is the first histogram located near the 0, and this is flattened and extended over the range. Go to the next slide. Here, a drawback for a histogram. Histogram equalization is not always desirable. Not always desirable. Okay. We saw some slides for improvements of enhancing the quality of image by equalizing the histogram. Okay. But in some cases, maybe it isn't good. In this slide, histogram equalization may not always produce desirable results. when, particularly, if the given histogram is very narrow. For example, this is our original image, some coins. Okay, you see, very located, very narrow histogram. Okay, in this area. If we use this equalization, okay, it can produce false edges and false regions. You see here, false edge, okay, false edge, false region, false edge, okay, and here you see flat, but here you see false regions, okay. It can also increase image graininess, okay. Graininess means this dot pixels, okay. This dot pixels means graininess. And patchiness, okay. What means patchiness? I search excuse me, I type in Google patchiness. Okay, patchiness is the same as graininess, okay? The same as graininess. In Persian, like dar budan, in Arabic is the same as kesafa, okay? The same as graininess. That's right. And another, the last slide for this time, this is the last. The histogram isn't completed, okay? This portion of the book isn't completed, but be for the next time. If there is any question, there's any question? Or one okay, this night اليوم أول أيام أو أول ليالي من أيام غدر. okay, من ليالي غدر. نلتمس بدعائكم. Who of you are in Najaf or Karbala? Or okay, that's right. نلتمس بدعائكم إن شاء الله. تكونوا بالسلامة. Okay, Mr. Yasser. Yes. What you typed? Okay. That's right.